Welcome to Module 6, Custom Functions. You've already learned about predefined functions in Module 4, which are built-in functions provided by the programming language. But now, it's time to take your programming skills to the next level. You can create your own custom functions. You can design and build functions that perform specific tasks, making your code more efficient, readable, and reusable. Before we dive into creating custom functions, you need to know that functions are declared outside the onTick function, not inside the onTick function. Now let's explore the properties of custom functions. A custom function can return different data types, including void, a function that doesn't return any value, int, a function that returns an integer value, double, a function that returns a decimal value, bool, a function that returns a Boolean value, true or false. Let's create a simple example using a custom function to compute the sum of two numbers. We'll define a function called addNumbers that takes two integers, a and b, and returns their sum. Here's the code. Int addNumbers, int a, int b, int sum equals a plus b. Return sum. Let's break down this code line by line. Int addNumbers, int a, int b. This line declares the function addNumbers with two integer parameters, a and b. The function returns an integer value, int sum equals a plus b. This line calculates the sum of a and b and stores it in the variable sum, return sum. This line returns the calculated sum. To call this function, you would use the following code. Int result equals addNumbers 5, 10. This code calls the addNumbers function with the arguments 5 and 10 and stores the returned result in the variable result, which is 15. Now, let's create another example using a custom function that returns a Boolean value. We'll define a function called rNumbersEqual that takes two integers, a and b, and returns true if they are equal and false otherwise. Here's the code. Bool rNumbers equal int a, int b. If a equals b, return true. Else, opening curly bracket, return false. Let's break down this code line by line. Bool rNumbersEqual int a, int b. This line declares the function rNumbersEqual with two integer parameters, a and b. The function returns a Boolean value. If a equals b, this line checks if a is equal to b. Return true. If a is equal to b, this line returns true. Else, this line is executed if a is not equal to b. Return false. To call this function, you would use the following code. Bool result equals rNumbersEqual 5, 5. This code calls the rNumbersEqual function with the arguments 5 and 5 and stores the returned result in the variable result. Since 5 is equal to 5, the function will return true. Now let's create a function that will print an arrow on the chart when our bullish and bearish signals, along with golden and death cross signals, are detected. Here's the function. Don't feel overwhelmed if this function looks complicated. It's normal to feel that way when encountering new code. The best way to understand this function is to code along with me. As we practice using this function, it will become easier to understand and use. Let's break down this function briefly. This function takes four parameters: time, price_level, color_code, and CLR. It creates an arrow object on the chart at the specified time and price_level with the specified color_code and CLR color. As you can see, I've declared this function outside the onTick function, not inside it. This is because, as we discussed earlier, functions should be declared outside the onTick function. Now that we have created the arrow function, let's see how to call it. To use this function, we need to pass four parameters. Time, the time at which the arrow will be plotted. Price_level, the price level at which the arrow will be plotted. Color_code, the color code of the arrow. CLR, the color of the arrow. To call this function, we need to declare these parameters inside the onTick function. Here's how we can do it. Let's break down these parameters line by line. Datetime time equals itime underscore symbol period underscore current 1. This line declares a variable time of type datetime. The itime function returns the time of the specified symbol and period. Double high equals ihigh underscore symbol period underscore current 1. This line declares a variable high of type double. The ihigh function returns the high price of the specified symbol and period. Double low equals ilow underscore symbol period underscore current 1. This line declares a variable low of type double. The ilow function returns the low price of the specified symbol and period. Now let's call the arrow function inside the if statement after detecting our bullish engulfing candlestick pattern above the golden cross. Arrow time low 233 CLR aqua. This line of code calls the arrow function, passing the required parameters. The arrow will be plotted at the specified time and low price level with the color code 233 and color CLR aqua. Similarly, for the bearish engulfing candlestick pattern below the death cross, we can call the arrow function as follows. Arrow time high 234 CLR red. This line of code calls the arrow function, passing the required parameters. The arrow will be plotted at the specified time and high price level with the color code 234 and color CLR red. Now let's summarize the overall algorithm that we have achieved. 1. Detected the golden cross and death cross. 2. Identified the bullish and bearish engulfing candlestick patterns. 3. If both conditions are met, the EA should generate a signal, and that's what we just did with the arrow function. 4. Created a custom arrow function to plot arrows on the chart. 5. Called the arrow function inside the if statements to plot arrows for the bullish and bearish engulfing candlestick patterns. We have successfully implemented the algorithm to detect bullish and bearish engulfing candlestick patterns above the golden cross and below the death cross, respectively, and plot arrows on the chart to visualize the signals.